now that we have seen basic definitions and basic theorems, we can talk about independence and mutual exclusiveness. So these two topics are somewhat confused. They are told that they are identical, but actually they are not. So independence and mutual exclusiveness, which is also called disjointness, are different concepts. A and B mutually exclusive implies that probability of A intersection B is empty set, or probability of A intersection B is 0. But A and B independent means that probability of A is larger than A, probability of B is larger than A. So probability of A intersection B is also larger than 0. Sorry, I said A, but they are larger than 0. Sorry. So these are events with non-zero probability, so they can both happen, and they can both happen at the same time if they are independent. So let's focus on this with an example. But before the example, let me give you the definition of independence of trials. So if an experiment has a sample space S, if the experiment is repeated n times, we speak of n trials of the experiment. The trials are independent if when the sample space can be, since there are n trials, sample space can be written as the multiplication of these n outcomes, where the n sample spaces, where Ti is the sample space of the ith trial, and probability of any outcome in these n trials is the probability of independent probabilities multiplied, like PT1, probability of T1 times probability of 2 times probability of 3 until probability of Tn. Probability of Ti is the probability of Ti in the ith trial. So this is actually important because in our cryptanalytic efforts, we will be performing n trials of an experiment. So this is why this definition is important to us. And in order to see how this works, or in order to better visualize this concept, let me give you a very basic example and try to solve it. So assume that a student is going to take an examination consisting of 4 true, false, and 3 multiple choice questions. Okay. So this is a very common example in probability theory books. So we can consider the solution of the exam as an experiment consisting of 7 trials. Each trial is an answer to one of the 7 questions. But don't forget that 4 of them true, false, and 3 of them are multiple choice. Assume that the true, false are the first questions, and the multiple choice are the succeeding questions of the exam. Of course, this is not important for the probability, but in order to better perform or better easy think about the question, let's make this assumption. The sample space then will be this: S equals to multiplication of 7 sample space, T1 to 7, and any outcome is actually corresponds to these sample spaces where Ti is answer to question I. So Ti can be either correct or incorrect, okay, in our example. So because a question is, your answer to a question can be correct or incorrect. Assume that the multiple choice problems have 3 choices. So this is important. For true, false questions, now you have 2 outcomes, true or false. But for the multiple choices, you have 3 outcomes. You are given 3 answers, A, B, C, and you need to pick one. So probability of randomly guessing the correct solution for the multiple choice problem would have a probability 1/3. But for the true, false questions, your probability of randomly guessing and winning is just 1/2. So you are more lucky with true false questions because the possible outcomes are less. So S consists of 7 tuples with components C's and I's, so correct or incorrect. So once a student writes 7 answers, like T1 to T7, we will say that this one is correct, this one is incorrect, and so on. So your 7-tuple component will be consisting of corrects and incorrects. We assume that the student is unprepared and chooses their answers randomly, which happens all the time. And this means that the answer to one question is unaffected by the answers to preceding ones. So here we are assuming the independence of tries. So just remember the previous definition. Question is, what is the probability of passing the exam if they answer at least 6 questions correctly? So you have 7 questions. In order to pass the exam, you have to answer at least 6 questions correctly. And the student is not prepared for the exam, so they choose the answers randomly. So question is, what is the probability of passing the exam if they answer at least 6 questions correctly? So I'm going to give the answer in the following slide, but this is a very nice example. I want you to actually stop the video at this point and, try to solve it yourself and see what the answer will be. You can, at the end, use a calculator if the computations are too much, but you can obtain a real value at the end. So please stop the video at this point, try to solve it yourself, and then see the answer and see if it is correct or at which part you made a mistake. Okay, so I'm moving on to the answer. So the answer is as follows. So we are trying to calculate the probability of passing. So you can pass the exam if you answer all 7 questions correctly or 6 of them correctly with 1 incorrect answer. So the probability can be divided into 2 as the addition of probabilities. So in one scenario, we calculate the probability of all 7 questions to be correctly answered. And in the other one, we will talk about the probability of having exactly 1 incorrect answer and 6 correct answers. So as you can see, these events are completely disjoint, so we can have the probability of happening both of them is actually the probability of one event plus the probability of the other event. So we can actually divide the first part into 2 separate parts because we have different kinds of questions. Because we have false true questions and multiple choice questions. So first, let's calculate the probability of the incorrect answer being in the false true answers. I think, let me see, yes, we have 4 true false questions. So assume that your answer to 3 of them are correct, 1 of them is wrong, and the remaining 3 multiple choice questions are also correct. In the second scenario, you correctly answer all true false questions, but you make an incorrect answer in multiple choice questions. So these 2 probabilities are added together to obtain this probability. But the last one is just the definition of this. You answer all 7 questions correctly, so you have the 7-tuple with all C's. So probability of passing is just now 3 probabilities added to each other because these 3 events are completely independent to each other. So let's first calculate the probability of having 1 incorrect in false true and 3 correct in multiple choice answers. So the answer is follows. If you correctly answer all 3 multiple choice questions, correctly answering one of the multiple choice questions has 1/3 probability. Since you have 3 questions, the probability of correct answering all multiple choice questions is 1/3 is multiplied by 1/3 multiplied by 1/3, so it is 1/3 to the power 3. And for the false true questions, you have to answer 3 of them correctly, so this is 1/2 to the power 3. But also probability of incorrect answering one of them is also has probability 1/2. This is why we have 1/2 to the power 4 here. but you have 4 questions, and you might have the incorrect answer to one of the 4 answers. So you have multiplication with 4 here. Actually, it is the combination of 4 with 1, which is also 4. So this is the probability of having 1 incorrect in false true questions and all correct in the other questions. Now we are going to do the same thing, but this time we are going to incorrectly answer the multiple choice problem. So in that case, as you can see, we have 3 multiple choice questions, so your incorrect answer might be in one of them. And you have to correctly answer 2 of the multiple choices, so this is why we have probability 1/3 squared. And we multiplied with the probability of you incorrectly choosing a multiple choice answer, which has probability 2/3, because 2 answers are incorrect and one of them is correct. And the probability of correctly guessing all of the 4 true and false questions has probability 1/2 to the power 4. So we covered this too. And the final part is correctly answering all 7 problems. The probability of this actually 1/2 to the power 4 multiplied by 1/3 to the power 3. So this is the answer. And if you compute this, you will see that the answer will be 0.02546 and so on. So this is the probability of a student who is unprepared and randomly guessing the answers and passing the exam. But interestingly, you can see that this is more than 2%. So if the exam is taken by 100 students and if all of them are unprepared and all of them follow this randomly guessing process, we can see that 2 or 3 students will pass the exam at the end. And for me, this is actually unexpected. It is this probability is more than I expected. So in our final exam, we will have true and false questions and multiple answer questions. So if you are not prepared now, you know your chances of winning. So please study for this course and for the final exam.